Let's see. First type, easiest type.
I'll start out.
You want to start with the hard ones first?
Yeah.
Let's start with the easy ones first. The easy ones. Oh, remember I got stuck yesterday on trying to prove that an exponential function was a one-to-one function?
When did we try to do that?
I tried to do that with the f of a equals f of b, and it doesn't work out because you really can only solve 2 to the a equals 2 to the b, knowing the one-to-one property. So we assumed that it was one-to-one to come up with the answer. The other way to prove a one-to-one function is to show that it is always increasing.
No.
Or always
Horizontal.
decreasing. It can't be horizontal, it's not one-to-one.
I meant horizontal line test.
Yeah, but that's after you graph it. But I'm saying you want to prove it absolutely all the time. You show it's always going uphill or always going downhill. It doesn't stop, it doesn't do anything. We could have done it that way, but it takes a little bit longer. All right, easy.
So x squared isn't 1 to 1?
X squared is definitely not 1 to 1, because it wraps back up around. You know, if you have x squared, it looks like this.
Yeah, well,
But if you do
said
the horizontal,
yesterday that it was 1 to 1 or something.
We changed it to 1 to 1 by cutting it and getting rid of half of that. So the easy one uses 1 to 1 property. Since exponential functions are 1 to 1 and logarithmic functions are their inverse, they're also 1 to 1. So we can use the inverse property and say, well, if I have f of a is equal to f of b, that implies that, well, they're 1 to 1. It implies directly that a must equal b. So we're going to use this property to actually solve equations. For instance, 16 raised to the 2x minus 1 is equal to 8 raised to the 3x plus 1. And I'm trying to solve for x. Why not?
Make them like base.
Now, there's actually 2 different ways to do this. Way number 1 is horrible. We could log both sides.
Yeah, that's what I was thinking.
We could bring the powers down.
Take forever.
That is the worst way to do this one. Some of them, it's the only way to do it. But this one, there's a better way. What's true about 16 and 8?
They have a like base.
They have a like base, which is 2. So 16 is 2 to the
2 to the 4th.
4th. And it's still being raised to 2x minus 1. And 8 is
3rd.
2 to the 3rd. And it's still being raised to 3x plus 1. Great. Now what?
So now you multiply the 4 and the 2x minus 1, and then you multiply.
Right. Power to a power,
Yeah.
you
Multiply.
So this becomes 2 raised to the
8x minus 4.
Is equal to 2 raised to the
9x plus 3.
9x plus 3.
I even cancel the bottoms.
Don't even say cancel the bottom.
No, you just make the.
F of A is equal to F of B implies the insides also
8x.
have to be equal.
So 8x minus 4 equals 9x plus 3.
Are the insides.
You're like a poof. The 2
Make
is
a
poof.
poof, yeah.
Yeah, you could say that, but it's not inverse poof. It's just
We're poofing.
It's just poof.
it's a recognition. It's not actually a poof. They're not algebraically or anything going away. You're just saying, oh, the domains must be equal. So we get x equals
-7.
-7. Hey, that's a nice answer. Didn't plan on that. I guess you could check it, but not really worth it.
I don't really care.
Not really. I don't really care.
I don't really care.
Yeah. Could you use 8 for that one too?
Could I use 8?
No.
I could if it was like 64. 8 and 64 have a common base of 8.
Good 8, because 8 can go in itself.
Yeah, but you can't write 8 as 16 as a power of 8. I mean, 8 raised to what power would be 16? Then you get into logarithms and it gets messy. So what you want is a very nice common base. How about this one? Log base 2 of x squared minus 6 equals log base 2 of 5x. This is simplistic. Well, since it's both log base 2 and they are one-to-one functions, then the domains must also be equal. So we say, well, x squared minus 6 must equal 5x.
Then you have to do.
How do you solve it?
You do pull the 5x over and then you factor.
It's a quadratic, move the 5x over, get it equal to 0. Factors of 6 is subtractive to 5.
Negative 2 and negative.
How did I do this?
I'm
Almost
sorry.
said 2 and
I'm
3.
sorry, negative 6 and positive 1.
Negative 6 and
Positive 1.
positive 1. So you get x is equal to 6 and x is equal to
Negative 1.
negative 1. Is that my answer?
No.
No,
Why?
then you have to see which one works.
Why didn't we do that over here?
Because there was only one answer. This
No,
one.
actually better answer. Why do we not have to check exponential?
Because it's not
Because the domain is all real numbers. So whatever answer you get is going to work. Why do I have to check with logarithms?
Hey, there, no guarantee.
There's a
Domain
domain
is
0 to infinity. If you got to be really careful with negatives. If I plug in negative 1, what happens to this side?
It become negative 5, so that can't work.
And that can't work. So we have to get rid of negative 1. Now, does 6 work?
Yes.
You better be careful. 36 minus 6, yeah, that's
does.
positive.
And
And then 6 times that is 30. So
Wait,
here's our answer.
Why does the negative one?
When you plug negative 1 in here, you get log of negative 5. What's wrong with log of negative 5? You can't do it. Oops. What the? I swear. Just get that out of the way. 22.
Section 3, 4.
This is still 3, 4.
What are we doing? Wait, where's the
Yeah.
What are we?
Solving equations.
Why'd you put 22 on?
No, that's why you don't have the book.
Now you're gonna have to make me open the book again.
Nah, you don't have to open the book. I'll copy it down. Don't worry. So it says e to the x plus 4 is equal to 1 over e to the 2x. Simple equation. So, how do you solve for x?
Make e to the negative.
I need the e on both sides, raised to some power.
Yeah, so you gotta take away the 1, but you gotta do that.
I don't take away the 1.
Okay, well you gotta get rid of the 1 somehow.
I don't get rid of the 1.
Then what do you do?
I take this
Multiply.
and put it
On the top.
in the top.
Yeah.
Now, if I
That's
put it
what
in the top, what happens to the exponent?
Put it negative.
It changes into a negative. So this is e to the x plus 4 is equal to e to the negative 2x. You want to get rid of the 1. It's still there.
It's still there, but you know what I meant.
That's
You know what I meant.
I know what you meant.
So if it's just 1 over anything like that, you can just move the exponent and make it a negative.
Yeah, because of this fancy law. 1 over a to the n is equal to a to the negative n. It's one of those laws of exponents, the fun ones. All right, now since the bases are identical and they're the only things that you see, you can take the domains and set them equal to each other. So, how do you solve for x?
Add 2x.
You could. You get 3x plus 4.
Negative 4 over 3.
Why would you do that?
I don't know, but that's what they said to do. So you get 3x is equal to negative 4, and x is equal to negative 4 over 3.
Yeah.
Personally, I would have subtracted x from both sides, but that's me.
Yes.
Doesn't matter. So you get x equals negative 4/3. Does it work?
No.
Yeah.
Yes, because exponential functions have a domain which is all real numbers, so it's going to work.
But if it was a logarithm, it wouldn't work.
It's
It
yeah,
might-
because it's negative. I won't say that because there are possible log equations where a negative answer actually works.
Oh, okay.
I can give you.
You have to plug it
No.
in.
It would work
You
on
have to
one
plug it
side,
in.
but it wouldn't work on the other.
The negative answer will work here. Well, yeah.
Yes.
You would get 4 minus x is equal to 5 because they're one-to-one functions, and x would equal negative 1.
It could equal anything in the negative.
Well, the thing here is when you take negative 1 and plug it in, it
becomes
generates a
5.
positive number. So it's not that the answer is negative, it's what happens when you plug it back in.
Yeah. Okay.
But ln cannot be 0 or negative.
But if it was if the answers was like negative 1 and 5, say. Like
5
wouldn't
won't work. Right, 5 wouldn't
Okay.
work. Hey, let's see. What's worse?
Question
Worse.
Oh, okay, so, girl, I'm so confused.
Which one?
No, not really confused. I just got my domain and ranges mixed up
Okay.
on something. He said that the domain for something has to be greater than 1. No?
I did.
Or the range?
The domain has to be bigger than 0.
Bigger than 0.
Yeah, for ln's and logs, they have to be bigger than 0. 0 to infinity. Cannot be 0, cannot be
You have to at
negative.
least set it equal.
Can't be equal to 0.
Yeah.
When you say this, the domain of this function is 4 minus x has to be bigger than 0, strictly. No equals, no nothing. So you get x is less than 4.
So what about the x equals negative 4?
This one's fine because it's exponentials. The domain is all real numbers.
The range is
Oh.
greater than 0.
The range is greater than 0, but you don't care about that. We're going to get an answer in the domain that works no matter what. Because the domain of an e function is all real numbers.
The domain
We have
of
to
an
worry
e
about the
function.
domain over here because it has to be
The domain
positive.
of an exponential function is all reals. And e is an exponential.
Okay,
And ln is
Not.
and what's the
Hopefully you never won't get this one.
no.
Gave it to, it was problem 102.
I'll
Give
look
me
at it.
one. I declare it.
I'll look at it later.
We need to declare war.
Let me pick out another one. How about number?
Remember quiz time.
Nah, not yet. 32. Got a ton of these to do. 4 e to the 7x is equal to 10,273. It looks horrible. It's really not.
Divide.
Now, this is not a one-to-one situation. This is something totally different. So, how do you think you would start this one off? I actually showed you how to solve this the
At
other
least
day.
divide it by 4.
Divide both sides by 4.
And
2,568.
what Sam said.
What Sam said.
2,568 for that number that you divided.
This divided by this is an even number.
0.25.
Yeah, that's what I wanted.
0.25.
So e to the 7x equals what?
2,568.25.
Okay, now what?
ln
ln and
ln it.
ln it. So ln both sides. See what happens.
What would e to the 7x become?
What's that?
Oh, you just, I'm sorry, that
Just
wasn't
gonna ln it and see what happens. So put an e to the 7x here. And
That would become 7x.
Yeah.
yep, that's the nice part. So if you ever have an e function you want to use,
ln.
ln's for sure. So this just becomes 7x because they're inverse functions. And then on this side you get ln of 2,568.25, which is easy enough to solve, right?
Yeah, hold up.
Divide by 7.
7.
When you type it in your calculator, it's going to be an approximation, so don't
1.12.
try not to put equals. What is it?
1.12.
1.12?
1568.
Yeah, 1.2. That sounds good. More than likely on a test, I'll ask you for the nearest hundredth, which is that. That's not that hard, right? Oh, come on, there's got to be harder ones here.
Like the one I gave you.
That one. I don't want to deal with that one yet. That one's boring. That's a hard one. I'll just make it up, though. I need more board space. The worst one possible.
No.
How do you do
What number?
It's not a number, well, it's similar to 42. But I'm just going to make it up, so I have no idea what's going to happen.
That's not
It's always good when I make them up. 3 raised to the 2x minus 1 is equal to 5 raised to the x plus 3.
See, that's simple. It's not.
Before, we tried to get the bases exactly the same when trying to solve for this. This is the absolute worst one I could put on a test for you.
You would have to make them so that when you power them,
Well, we're going to do something to it. It's going to be a mess. But I can't make 3's into 5's or 5's into 3's. They're prime numbers, so I'm stuck with it. So what's another option of solving this equation?
least common
Yeah,
Log of both.
log of both.
denominator.
See what happens. Do you want to use LOG or LN?
LOG. When you're using E, can you use log?
You can.
But it would
Um,
be harder.
If you did it over here, you'd have log of e to the 7x. The 7x would come out front, and you'd have to divide by log of e.
But you would get
7 and log of e. it's messier. So if there's an E, use ln.
So you don't have to do the 7x in front of ln.
Oh, whatever you do, log or ln, that 7x has to come out front.
Well, how come you didn't
I did.
do that? Oh, okay, I see it. They just cancel out, that's all.
ln of E is equal to 1.
That's why it's just easier to use ln.
Yeah, because it just goes away.
Alright.
But here we're kind of stuck. ln, log, nothing happens special. So it's log of this
Now we're going.
equal to log of this. And that's just the beginning.
Put the powers out front.
Throw the powers out front. Be careful with the powers though. When I write 2x minus 1,
You have to put them together.
keep them in parentheses. So this is going to be 2x minus 1 times log of 3 is equal to x plus 3 times log of 5. Now writing log of 3 and log of 5, we're going to have to write it like 10 times.
What do you do 2x log of 3 minus log of 3?
That's the thing. I don't want to write it over and over and over again because as we solve this problem, we'll have to write log at least 10 times. So I'm going to do a little algebraic trick. I'm going to go off to the side and say, let capital A equal log of 3. Let capital B equal log of 5. What that'll allow us to do is to write one letter to represent the whole thing. So then this boils down to
2xa.
log of 3 is A, so you get A times 2x minus 1 equals, and then log of 5 is B times x plus 3. It just looks a lot nicer. It does.
Would you?
Solve for x, of
You
course.
mean divide by?
Distribute out both of them. So this is 2ax minus a is equal to bx plus 3b.
So is that the only way we're going to solve it?
No, you could leave log 3 and log 5 in there. It's just you're going to have to copy it down a million times. Or do you mean, is this the only method that's going to solve it?
Like log,
No, like the A's and B's.
You don't have to. I'm just saying it'll make your life a lot easier.
pretty
Because
much.
otherwise you'll be writing 2 log 3 of x. And that looks... And you can get confused where that x is. So if you just put a and b, you don't lose fact that it's just a number.
Like 2 log 3 of
Yeah, this would be 2 times log of 3x minus log of 3 equals log of 5x plus 3 log of 5.
So
It just
this
gets
is 2
messy.
of 2 of the log of 3x. Can you just write it down normally first? So
No.
It would be 2 log 3 times x minus log 3. I mean, just... ugh.
Why would it be 2 log 3x?
2?
Why can't you just
Just
do
a 1.
2x log 3?
Because you don't have
I guess you could, but what's the difference of order? It just looks... It's long. This is...
I know,
Sure.
I don't care how you write it.
So, if we're going to solve for x, what's the next step?
Combine it.
When you're solving a linear equation and you're trying to solve for x, what do you try to do?
Isolate the x's.
Get the x's on
One side.
and get all the junk on the...
Add
Other.
A over.
on the
So,
movement.
BX.
Don't touch a, you're concentrating on the x's.
I'm trying
Move
to
the
get
bx over, and you get 2ax
Oh, I was gonna do the other way. So.
minus bx, shift the a over,
That's what I was talking
3b
about.
plus a. Your focus should always be on what you're
You
solving.
could
That's
isolate
what
an
I'm
x.
doing.
Isolate an x how?
Make it x times the quantity of 2a minus b.
X times the quantity of 2a minus b is equal to 3b plus a. So far we've saved a ton of time because I don't have to write log 3, log 5. I'm just writing a's and b's. And then x is going to equal 3b plus a over 2a minus b. Now, you can go back to the numbers now, the real numbers. And this is 3 times b. What's b?
Log 5.
Log of 5. All right, plus a. A
Log
is
3.
log of 3 over.
Can you write this in like regularly? Because all the A's and B's are confusing right now.
Trust me, the log of 3 and log of 5 would be worse. I'll do one the other way to show you that it's horrible. A is
Log of 3.
log of 3,
You just throw it in there and you solve it.
and B is Log of 5.
Do you want us to move the, made it so that it's log 5 cubed or not?
Ah, now that's a choice. If you can type that into your calculator without making any mistakes and getting the right answer, you could leave it like that. But is that the best way to leave it?
Probably not.
Probably not. The best way to do it is, yes, put the 3 on the 5. That becomes 125. What's the plus mean?
Plus
Multiplication. So it's 125 times
3, which is 375.
375. So this is log of 375 over, this is 3 squared, which is
9.
9. This is divided by
5.
5. So this is log of
9/5.
9/5. That's much easier to type in a calculator.
Can you repeat that?
Using the laws of logarithms, the 3 goes on the 5 as a power. 5 to the third is 125. The plus sign means that the insides get multiplied, so you get 125 times 3, which is 375. 2 goes on the 3, becomes 3 squared, which is 9. The minus sign means division, so the 5 is in the bottom, so it becomes log of 9/5.
It's going to be
Yes.
10.0.
Whoa.
10.0.
10.0?
8.
Approximately.
Yeah.
3 fours.
Now, if you can just type it in from here and get an answer, I'm not going to stop you, but you have to put a parentheses here, parentheses there, parentheses here, parentheses there to get the right answer.
And then you always have to close the parentheses.
You have to, yeah, close all of those parentheses. So sometimes using laws of logarithms just makes life a little bit
Can you
easier.
like let us copy that down, please?
Yeah, go ahead. I'm going to do another one for you without the A's and B's,
Well,
just to show you how horrible it is.
Can you wait like 5 seconds then? Like, I'm trying to call it.
I'll take a nap while you're dead.
what did 375? Let that from
5 cubed
Oh, you don't add.
times 3.
Oh,
Remember, plus between logs is multiplication between the insides.
15 to the third. Okay, so
Yeah.
okay.
No, it's not 15 to the
Yeah,
third.
you do 5 to the third and then
It's
times it, yeah.
5 to the third times 3.
Okay, so
I don't.
But now, I just learned from my mistake.
Where you put the 2ax minus bx equals 3b plus a. Why didn't you switch, yeah, that one. Why did you switch the a to the other side and b to the other side? Why didn't you keep them the same?
Oh, you mean, why did I bring him over here?
Yeah, like why didn't you keep the two a's together and the b's together?
The A's and B's are irrelevant. You're solving for X. If you were solving for A, yeah, you want to keep the A's together and the B's together. But we're trying to solve for X, so here's an X and here's an X. You want to get them on the same side. That's why your focus should always be on what the heck are you solving, and not moving pieces that are irrelevant to X.
Huh?
Sam.
What?
Want me to do an ugly long one now without A and B?
No.
Without A and B. 2 raised to the 4x plus 3 is equal to 7 raised to the 2x minus 1.
Let's write down.
Go.
Now I'm going to skip a few steps because they're very similar. So we're going to log both sides and the powers are going to go down out front. So this one is going to become quantity 4x plus 3 times log of 2 is equal to
Quantity 2x minus 1.
2x minus 1 times
August 7th.
log of 7. Let's leave them in there. Oops, do log of 7. Ooh, what's that? Strange. All right, so now we have to distribute. So you distribute this in to both of them. I think I'll write it as 4x log of 2 plus 3 times log of 2 is equal to 2x log of 7 minus log of 7. Do you see where this is ugly?
Can I just do it in the
Yeah, please. I'm just trying to show you that right now my AB equation is only this long, maybe 2 feet. This thing is 3 to 4 feet on my
Why
board.
didn't teachers teach
It's
us
almost
this?
as tall as me.
It makes more sense to me.
For some people, understanding that algebra is the representation of numbers by letters just avoid, they just right over their heads. I don't know why. You've been doing algebra for years.
I just makes me nervous.
It shouldn't make you nervous. It should go, it makes it cleaner.
I know.
All right, then these two have to go on the same side, and you're going to factor out a x. So this becomes,
Can you, like, not go on ahead? Don't factor out the x yet.
no, I'm going to bring them to the same side and factor out an x.
Don't factor out the x yet.
Ah,
Why are
Fine.
you putting the things on the log of 7 on the same side?
huh?
Couldn't you factor out a 2?
Okay, when I'm at this line right here, what am I solving for?
X.
X. There's an x over here, and there's an x over here. That's all your concentration should be on, nothing else, just the x's. Now, when I get the x's on the same side, I get 4x log of 2 minus
sorry,
2x log of 7. And I'm going to shift him the other way. So this becomes negative 3 log of 2 minus log of 7.
Oh my gosh, I am so sorry that I made you write all that,
It's horrible.
but
Kick out the x.
I can't do it the other way.
Alright. Left behind is 4 log of 2 minus 2 log of 7 is equal to, well, this mess. I'll use an English cheater. Copy it down. And then we're going to divide this across. So x is going to equal negative 3 log of 2 minus log of 7 over 4 log of 2 minus 2 log of 7.
Oh my god, it's so much writing. That's so bad for you. I'm sorry.
I'd rather do my A and B any day of the week. So, what do I type in for the top if I want to combine those two logs? So it'd be log of what?
2 to the negative third is 1 over 8.
Don't do the negative. Just do the, you know it's going to be at the bottom. So it's 2 to the third, which is 8, times,
No, divided by.
times,
It's minus.
we know it's in the bottom, times. Think of it this way. Make this plus, factor out a negative.
No.
So it's 2 to the third, which is 8, times 7 is,
56.
and it really goes in the,
Bottom.
so it's log of 1 over 56. Ugh. All right, down here, this is,
You are
Log
complaining.
of 16 over
you could do it the other way. You'll get the same answer. So this is 2 to the 4th, which is
16.
over,
16.
I don't know.
Hold up.
7.
49.
49. So this would be log
16.
of 16 divided by 49.
Okay.
If you don't like that, put big old parentheses around that huge ugly expression, type it all in your calculator, and have a good old time.
No thanks.
But I like you practicing those laws of logarithms because they do come in handy.
So the answer is,
Whatever the heck your calculator tells you it is.
I'm about to see.
I highly suggest using the A's and B's, that way you don't get confused. Because even when I was doing this, I got lost that X I was factoring out. I was going to copy it down again. And that really would have messed things up. So, just an idea. How about number, ooh, here's a good one.
No.
I got 3.596.
3, 4, 5, 9, 6? Anyone?
I don't know.
Okay.
Wait, that
Sounds
was
good.
Yes, that is what it is. You don't
For
want
your
to
x
type that.
equals, you got
Five
you put a
times
plus, and then up there you got a minus.
Okay, it was minus minus. I factored out a negative.
Actually, it works like.
And what that does is it comes up as a power on the whole thing when you're done. So it becomes in the bottom. It would become 56 to the negative 1 power, better known as 1 over 56. That's because Mary Catherine decided to argue with me that one was in the top and the other one was in the bottom.
Oh my gosh. Really? It's my fault?
Yes, your fault.
No.
Yes, it is.
No.
You're explaining to people.
I do. Number 48. This one's pretty bad too.
Well, then why are we doing that?
Because I'm going to ask it on the test. 48. 2 to the 2x plus 2 to the x minus 12 is equal to 0.
I like it that
You
way.
can
Just do it
combine
like
2 to
that.
the
Yeah.
2x and 2 to the x.
No, you cannot.
No.
They have the same base though.
They have the same base, but powers are different.
So you can,
It's a
This would be like x cubed and x squared. You can't add them together.
I'm thinking,
I know what you're thinking, but you're thinking they're multiplying. They're
yeah.
adding. So what does it look like? What kind of equation does it look like?
It looks like a quadratic.
It looks like a quadratic. So this is what's called quadratic form, and the only way to undo this one is to use this trick. You choose a new variable, call it u. Call it anything you want, just not x. And you let it equal the middle variable part. Well, what's the middle variable part? 2 to the x. Then you take u and you square it. If you square both sides, you get u squared equals
2
The X.
2 to the x squared.
2x.
Oh my god.
2 to the 2x. 2 to the
Hold
2x.
hold
2
on.
to the 2x.
2 to the x squared,
2 to the 2x.
which is power to the power u,
Multiply. 2 to the 2x.
and the base does not change, so
2
it's
to the 2x.
2 to the 2x.
Oh my God.
I hear you, Mary Catherine. I want to make sure everybody else is on the same page. Now, the reason this works is because after you square it, it becomes the first term.
Yeah, so then it can be what, like 4?
U squared
4.
plus this get replaced with
U.
u. That's what we chose. Minus 12 is equal to 0. So this quadratic form, this is the method you always go. You let u equal the middle term, you
But
square
does
it.
that always work?
If it's quadratic form, it'll always work, guaranteed.
Oh.
If it's quadratic form. Now,
What
If
it
you
looks like
square it-
quadratic form and it's not?
if you square it and it does not turn out to be that, then you can't do it.
Can you do one of the one?
I will never give you one that doesn't work.
Okay.
What's the point of giving you one that's not going to work?
I don't know.
I'll begin to wonder.
Just to trick you?
Yeah.
You want to be cruel?
Do that.
So now.
All right, factor.
U plus 4 times U is minus 3.
U plus 4,
U minus 3.
u minus, darn it, 4, u minus 3. So then you get u is equal to negative 4 and u is equal to positive 3.
Great.
Except for one problem.
You gotta see if it works.
We're not solving for u, we're solving for
X.
x. So you have to go back to this and replace the u with what it's really equal to. U really equals 2 to the x. And we're saying 2 to the x equals negative 4.
That can't
And
work.
this one over here is 2 to the x is equal to 3.
That won't work. Negative 4 won't work.
This one won't work because 2 to the x is never ever going to be
Negative.
negative. So that one's not going to give us a solution. But 2 to the x is equal to 3 should work. What's its answer?
8.
How do you find it?
You do log.
8. No.
No, it's like no.
2 to the 8th? I don't even want to know what it is.
Log base 2 of 3.
No, well, you
Equals
could.
x.
You could do that. You could say,
Log 3
this is log base 2 of 3 is equal to x. That does solve it for x, except for one problem. I'd rather you get it into something that's like calculator form.
That is calculator.
No, calculator form would be x is equal to
Log of 3 over log of 2.
log of 3 divided by log of 2. You could do change of base formula. At the beginning here, you could have logged both sides and came up with the same answer. Any which way you can get about it. That's not that bad, right?
Let's do wrong. I don't know that.
Wait, that's the answer?
That's the only answer.
Okay.
The other one doesn't give us a solution.
Brain hurt.
Alright, does it get worse?
So you want us
I
to do
didn't.
that, not the different one?
I mean, I guess you could leave this, but you can't type that in the calculator and tell me what it is
I
approximately.
mean, for that one.
Yeah, if you leave it like this, I'm happy. It's an exact answer. You type it in the calculator, you're giving me decimals and it's an approximation. I like exact. How about number 58?
I can do log base 2 of 3 on my calculator.
Yeah, yours, but the 83s don't do that. At least I don't think they do.
No, but now.
And even if it did, I could care less because it's easier just to type it in like that.
It's not.
It is.
To find it in the menu system.
Oh no,
And then to
I
use
just found
it.
it perfectly fine. It's log
Which
base
one did I just say? 58.
58.
58. Log base 2 of 4x plus 1 is equal to
5. It's equal to 5.
5. Okay, now I couldn't. Alright, how do you solve this one?
2 make it log base 2.
You make it
Exponential.
You have to
an
make
exponential.
Which
The base is
2.
2. The power is 5. And it's equal to?
4x
Where's-
plus 1.
Remember I told you the conversion from log to exponent to log will solve about half of the problems you're going to have? That's the type I was talking about. What's 2 to the 5th?
32.
So this is 32 minus 1 divided by 4 is equal to x. I just did a bunch of steps at once.
7.75.
Clever cat.
It would be
You're going to subtract 1 and divide by 4. So this is 31 over,
7.75.
I'd rather you leave it as 31 fourths.
Okay.
What is that?
I don't like decimals either. Unless it's a word problem.
I don't
So
like fractions.
that one's not too bad.
What's
What's worse? Number 68. That's worse. 68. Log base 2 of x minus 1 plus log base 2 of x plus 1 is equal to, and I lost it already. 3? 3.
Three, buddy.
Doesn't even matter. Just put another number on the other side and be happy. All right. Now this one I could have just run right to an exponential form. Can I do that one right to exponential?
No.
What can I do first?
You have to multiply
You right.
I can combine the logs,
and
squish them together.
Maybe.
A plus becomes,
multiply
times. So this is log base 2
x
of,
squared minus 1.
well, I'm not going to
Oh, I'm
skip a
sorry.
step. And it's equal to
3.
3. But it is
Oh,
x squared
that's
minus 1.
minus 1.
So this becomes 2 to the
Third.
third in exponential form. X minus 1 times x plus 1 is x squared minus 1. They're conjugates.
It equals 3.
It's the difference of squares.
X equals
It's 8.
You be quiet.
3.
This is 8. Add on 1, you get
9.
9. So you get x squared is equal to 9. So x is equal to
Plus or minus 3.
plus or minus 3. But if I try to take negative 3 and plug it back in here, what happens?
It becomes a negative in the first one.
So the only answer we get is x equals positive 3. The negative 1 does not work with ln or log. So if there's pluses and minuses, you can combine them as a single log and then solve it. For instance, I'm going to make up one, unless they have a good one there. Well, that's not bad. 70. That's kind of boring.
Right, let's do it anyway.
Yeah, it's boring. 70. Log base 4 x plus 2. X plus 2 minus log base 4 of x minus 1. And it's equal to a boring 1. Yay. Now, I can't change it to an x.
No.
Oh, okay. I can't change it to an exponential yet, so I have to take care of the subtraction there, which makes it a division problem. So you get log base 4 of
X plus 2
x plus 2
Over x.
by X minus 1.
over x minus 1, and this is equal to 1. So it becomes 4 raised to the, like I said, boring.
4.
So you get x plus 2 over x minus 1 is equal to 4.
Multiply by X minus 1.
Multiply to get rid of the denominator. You get x plus 2 is equal to 4 times x minus 1.
X equals 2.
I'm not sure yet.
It's you that.
3x, 6. So 6 equals 3x.
2.
And x equals 2. Does it work?
Yes.
I hope.
It works.
Log base 4 of 4 is
1.
1. And this is 2. 2 minus 1. Log base 4 of 1 is,
0.
and 1 minus 0 is 1.
1.
It works. So subtraction just becomes that. Do they get worse?